Yeah, so thank you very much for the invitation to present here. Let's say regarding the topic of smart farming technologies, let's say a few more of Middle European smaller structured agriculture farms with a very family-orientated history, like in Austria or in the south of Germany, also like in Bavaria. So there we have maybe also a special condition and a special view on the topics we are dealing with. So with the presentation, I will give more or less an overview what are our traditional perspectives and the historical perspectives from agriculture engineering, the specific view from this site, and what could we expect regarding the new technologies we are. So I'm very sorry so that is also a reality with digitalization and smart technologies we have to deal with just now with a lot of burdens to overcome it, yes. So I just give the next slide to keep the time, to keep us in time a little bit. It shows you just an historical overview. You have to press several times. These are these numbers, 1, 2, 3, 4. If you just press the next buttons, please, for the animation. So we are dealing now with the question Agriculture 4.0, and just the next, you can put several times, maybe 6 times now to see the whole slide. So it's a historical overview of that, what happened from the early beginning. That just keep on pressing the next slides. Yes, go further, please. So we come from the early stages of mechanizations, steam machines, and so on. So you can put three further steps, 3 steps further in the presentation, where we can, 3 times the animation. I'm very sorry for these problems. So there are 4 main developments in the past, and now we are actually, if we have a clear look to that, what is agriculture now, we are not reaching agriculture 4.0. We are just in the process to implement this technology of electronics, sensors, and so on, and that is related to the industry 3.0, clearly per definition. So everything what we are talking about 4.0, it is just in development, step by step, but with a high intensity and a lot of activities. So just press 2 times further, please. One more. So if we have a look to the international journals, like journals from the CIGR, next slide, please. Then we can see that already in the early 90s, from the CIGR, the World Association of Agriculture Engineers, this was the cover of a special issue related to precision crop farming. So the technology we are dealing with today, already 30 years later, we are still, if we have a look to practice situation, in the development. Some things changed and were added, so chip cards, they disappeared. We are now connected online by mobile phone, by smartphones, etc., etc. So the ICT, information communication technologies, they developed quite a lot. Next slide, please. And so these applications we are dealing with in the future. Next slide, please, or next animation. The big question will be, could be the smartphone in the future something like a Swiss Army knife? And if we look in the different production systems next with precision farming, we have the same similar developments, next animation, in crop production and also in livestock farming. Like here you see robotics, or also tractors which are without any drivers, or identification of animals with special sensors to monitor animals online with their health status, with their productivity. Milking robot systems, for example, they develop step by step more sensitive for to manage single cows individually, for example. Next slide, please. If we take into account a publication made by the president of the Max Planck Institution, let's say this is one or the number
Просим
one.
следующий слайд.
Next slide, please. Yes, of the German scientific community. So he mentioned that we are on a border in a new century, which could be compared something like Gutenberg with where we changed from oral to written books, from oral communication to written books. And so he mentioned that we would be in a paradigm change in a digital world, and that was 2016, and every sector of our daily life will be affected on that. On the right side, you see just a survey done in Germany in the year 2020 on 500 farms with the question, how far implemented are tools of smart farming technologies in our farms yet? And that was quite interesting, that over 80% of the farms, they say they are planning to implement smart farming technologies in their farms, but only 8% already they mentioned that this technology will be not relevant for them, only 8%. So, and on the other hand, for our perspective, I know for Russia it's just something to laugh about. Farms with hectares more than 100 hectares in Germany are more bigger farms, or in Austria also. For Russia, okay, that will be a little baby farm, I know, but nevertheless, you see also the smaller little bitty farms with 30 to 50 hectares, around 60% of the farmers, they also see that in the future, smart farming technology will play a big role for them. So next animation, please. So for future developments, tremendous changes have to be taken into account. Please go further, twice. Oh, can you hear me? Oh, I think. Yes. So,
Yes, we hear
okay.
you.
Okay. So what are the open questions we have to deal with? The first, we have to have a few, which it's called a more system engineering approach to fulfill. So you have to find a clear picture, imagination, what are the system levels we have to deal with in agriculture. Next step, please. The second question will be, what are the structural relationships we have to describe to understand what in the system, what are the factors playing together? And the third one, of course, which parameters we have to take into account, we have to measure, we have to be aware, we have to quantify to understand how the systems really are existing. And all together with this, the next question, to aggregate these parameters together, we get the next step into to allow us to have a qualitative assessment of that. And so in the next logical view, we have to implement in the agriculture or biosystem engineering approaches the tools of system analysis and system structures just you can go further 3 times. So I just step over this, what you see here, because this is a special methodology, but we have to implement this methodology in our agriculture biosystem engineering toolboxes. So what agriculture or biosystems engineers have to focus on in the future? That was a big discussion also in the community of the Club of Bologna, a global community of agriculture engineers. Also, I remember Oleg Marchenko from Russia attending here for decades, I think already, with a warm memory on him. Yes. So back to this, the hypothesis I wanted to stress would be what if we relate this question to our topic of digitalization in agriculture and biosystem engineering. The first step is to define the system architecture and to assign levels, relation parameters. So which are the levels? We see here 5 levels. From a sub-process, next step please, which could be chips on single plant or animal cells with a connection to the internet. So that would be the smallest size of IoT technology, which is based on single cells, and that up to a global approach. And with all these informations from these different levels, we will be connected online regarding weather, regarding people with taking informations directly from animals or from plants. Informations from machinery, also from the logistics, post-harvest processing, and so on, in the food design. In the end, we have a big pool of data. We have a sea of data, and we are lacking for information. So the important thing will be how to connect all this data to create out of this data informations. And there the technologies and tools which are named like artificial intelligence, etc. These methodologies will take a big place in the future, because in the end we want to reach also the level of assessment. Next, press once more please. And assessment with a focus of course on costs, but also on a lot of aspects which are related to the so-called sustainability development goals of the United Nations: nature, climate change, poverty, etc., etc. So, but the data we can get from the single cell up to a global or scale could be in the future connected to find answers for these questions. So next slide, please. Once more. So if I want to give you some examples. On the simple level, we are already now in the situation that we are able, by, for example, modern camera systems in the multispectra, in the multispectrum, to develop sensors which we call superficial eyes, directly on plants or from drones or also from satellite data, etc. pp. But connected with intelligent mathematical tools like deep learning procedures to detect single plants, to detect plants in the field, and that with the information online transferred by ICT technologies with respect, for example, to nitrogen status, chlorosis, necrosis caused by plant diseases, and so on. And with the ICT connectivity, the interesting developments in the huge increase of data transfer rates which are available, we can open completely new doors in online processing from fields on several locations. Or the same next on the sub-process specific level, please, the next step or slide. Please, we are jumping a little bit further, but that is just an example I can give you. Just if you press once more, a typical process of winter wheat production, where we just changed the production technology in an example of nitrogen fertilization, where with a sensor technology, square meter by square meter, is managing the variability of fertilization in the field. But nevertheless, from all other steps, we receive the data of the whole process all together, so that in the end, we are able to evaluate the whole process, and that means that the inputs above and the outputs below put together, they can deliver us the data, transparent data, to manage the whole thing with respect to life cycle assessment, life cycle costing, and for farmers in the future also to get answers on a lot of questions with respect to multi-criteria analysis. So please, the next slide. Once more, and once more. Yeah, and again once more, sorry. So what have we to focus on as agriculture engineers? If we step further from the levels, so we go now from the sub-process level, we are now on the overall process-specific production. A lot of tools are already available. So one important sector is the telemetry, of course, to know what the machines and IoT sensors can deliver and can be connected online in a farm management information system. And with respect to this, we can get further one step. Please, also the next step in the presentation.
Dr. Andreas,
yes?
2 minutes, excuse me.
Okay, I'm just two further slides. We reach the over farm related level, so that we can have a transparent value chain with high potential in optimization for the farms on the one hand, and also to interconnect consumer to the farmers directly, much more, so that the whole thing, the whole production and food production in the society gets more transparent again. Next slide, please. So yes, again, so that we have also the possibility to interconnect on the company level, not only farms, also the industry in front of farms, like implement producers, fertilizer producers, seeding companies, etc., etc. And on the other hand, also the distributors of food within in the end. And that not only on a regional level, please next step, also on the level of a national or global networking of producers, consumers, the whole agriculture community. Next slide, next step, please. Yeah, and one further. So the question is, what are the challenges for the future? That is my more or less last slide. Challenges. What are the challenges? Data collection and online availability is one important point. Compatibility of machines and implements. Still, companies are not normalized, are not normed in all implements and machinery that plug and play the technology is working. There are some burdens to overcome. The same will be on the topic of compatibility of data formats, data storage and transfer capacities. And a very important point is the question of data safety and security. So that are the needs we can put together. And if I have a look to the work I'm doing at the university with the students on the one hand, or on education of farmers, we have a big lack in education. So that means that we need education on the European nomenclatura. It is the so-called European Qualification Framework, EQF levels. That means from apprentice training up to the PhD education, we have to do, we have a big work in front to implement all these knowledges in interdisciplinary approaches in our education activities overall. So to give a last example how it can work, from my colleague, the Club of Bologna member, John Schiller, he was working just 2 times, the next slide, please, in Africa, where also here on very simple level, 2015, they tried to connect the irrigation, solar irrigation, drip irrigation system via smartphone to manage it from abroad, optimized irrigation. So also this example, they show that these technologies are not only technologies for big farms, they are all embarrassing all our daily life, as I have shown before. So I will just resume with the final statement. We have not just, you can read also later on, and so you can go to the last slide of my presentation. I'm very sorry for the problems I was causing here during this presentation. And yeah, спасибо большое.